Hey guys, welcome to the video for writing quadratic equations. We're still in Unit 7A. Our essential question is how can quadratics be used to solve real-world problems, and how can I rewrite equations in intercept form? So intercept form is an informal form that we learn. It is a useful form because you do see it on STAR occasionally, and it's also known as factored form. So before we get into any of that, we're going to review a little bit because we're going to need the review skill in order to solve and write the equations. Not solve the equations, just write them. Okay, so we're going to review a concept that we learned when we were learning how to write equations in vertex form. So we're asked to write an equation in vertex form given the vertex -3, 4 and the point -6, -4 on the parabola. Okay, now we're asked to write this in vertex form. Remember, vertex form is y equals a parentheses x minus h parentheses squared plus k. And remember, the vertex was denoted by h comma k. So vertex h comma k. But in this case, what is our vertex? Well, our vertex here is -3, +4. And then we're also given a normal point on the parabola, -6, -14. So let's, oops, I need to write point next to that. Okay, so they give us a random point on the parabola and the vertex of that parabola. So I'm going to go ahead and show you what is happening here. So we're given the point -3, 4 and the point -6, -14. Okay, so they're giving us 2 points here. And they're going to ask us to, is it -6, -14? Oh, yep, it is. Okay. Now they're giving us 2 random points, and they're asking us to graph this. Not really graph it, but write an equation for it. So that's what we're going to do. So they're giving me a vertex and a point. So I have to use that information to help me write vertex form. Well, for vertex form, what do I have so far? Well, if I plug in the information that I know that I need the vertex, right? So I have y equals a parentheses x, and then what's my h? It's going to be +3. And then my k is +4. Is this my final answer? It's not, right? Because I don't know what a is. I need to have a in order for my vertex form to be complete. So we're going to use the information that we have to solve this. Remember, vertex is h comma k, and then a regular point is just x comma y. All right, so we're going to plug in the information we know. Well, for the y value, I'm going to plug in -14. Equals a, and the reason why I still have a is because I don't know what a is yet and I need to solve for it. Parentheses, well, what's the x that we have? -6. Remember, I labeled all of these, so I'm just plugging them in as I see. Now we have minus h. Well, our h here is -3, but when I plug it in, it's going to be +3, parentheses squared. I'm going to fix this negative sign. Okay, and then I have k. Well, my k is just going to be +4, and that sign stays the same. So I've plugged in everything I know except for the a, which I don't know. So now I'm going to simplify this. The first thing I'm going to do to simplify this is subtract 4 on both sides of my equation. And I'll go ahead and draw a line to help me out here. So that's going to go away. -14 minus 4 is -18 equals a parentheses -6 plus 3 squared. Well, what's -6 plus 3? Because I can simplify that, right? Right? I don't want to double distribute. I don't want to write it twice because it would make it more complicated. So I have -18 equals a parentheses, well, -6 plus 3 is -3. Parentheses squared. Now, when I plug this into my calculator to help me find what this is, -3 squared, you need to use parentheses, or it's not going to give you the right answer. So we should have -18 equals a times, well, what's -3 squared? It's +9, right? Now, I don't want to write 9 on the side because then it looks funny. So I'm going to write 9a. And then my very last step is I want to get a by itself. So I'm going to divide both sides by 9. When I divide both sides by 9, I get a equals -2. Is this my answer? No, but it's part of my answer, right? I need it in order to write an equation in vertex form. So let's go ahead and write down what we know. Well, vertex form is y equals a parentheses x minus h squared plus k, right? And I'll go ahead and write it in yellow so it can match what we have above. Okay, well, when I write my final equation in vertex form, I want to plug in my a and my vertex. I want to keep x and y in the equation because every equation of a quadratic needs an independent and a dependent. They all need x and y. So I'm going to leave y empty, okay, and what is my a value? Well, my a value is -2. Now, did the problem give me the a value? No, right? I had to solve it. They didn't give me that, so that's the reason why I had to do all that work. Parentheses x, and then my h here is going to be +3 squared plus 4. So notice I don't use the point in my final answer. The point is just there to help me solve my problem, which is I don't have a. That's the problem I had. But once I have solved my problem, which is finding a, then I don't need that point anymore. So let's go test out and see if this equation actually gives us a vertex of -3, 4, and it goes to the point -6, -14. So I'm going to go to Desmos. Now remember, those are the 2 points that we were given. Y equals -2 parentheses x plus 3 squared plus 4. Does our green equation go through the vertex and the point? Yeah. The red point is the vertex up there, and the blue point is a point that goes through our parabola. So we did exactly what we needed to do. So that is review. Okay, now we're going to learn about intercept form, which is also known as factored form. The reason why it's called factored form as well is because it kind of looks like when we did factoring. So you remember when we would do factoring, so like we'd have x and then x minus 4 and then like plus 2 and then like x minus 4. So our parentheses matched and we're like, okay, that's good. And then we wrote the outsides, we put that on the one set of parentheses, and then we put them matching, right? So these were factors. Well, factored form looks really similar to this. Now, factored form also can sometimes have a number in the front. For example, if I had like a 3 in the front. Well, where did this 3 come from if I was factoring? That usually came from my GCF that I pulled at the very beginning. So we would have 3 different things being multiplied there. So intercept form looks like this. Y equals a, parentheses, x minus p, and then x minus q in parentheses. So that's a p and a q, not a 9, okay? It is a p and a q. All right, so why is it called factored form? Well, it kind of looks like factors, right? Like this kind of looks like your GCF, this kind of looks like one of your factors, and the other one looks like a factor. But it's also known as intercept form. And the reason why it's called intercept form is because it gives us the x-intercepts. Now, how do I know it's the x-intercepts and not the y-intercepts? Well, in your parentheses, what variable do you have? You have x's. So I'm going to go ahead and show you what this kind of looks like in Desmos, okay? So I'm going to write down a random equation. Y equals 2 parentheses x plus 3 and then x minus 4. Okay, so notice that in my purple equation up there when I wrote it, it's an intercept form. It kind of looks like when we would factor it. Well, this is my quadratic. Let's go ahead and tap on my x-intercepts, my solutions here. And I tap on both of them. Whoops. Now, what do you notice? Well, the numbers are very similar to the numbers that are in my parentheses in the equation. Well, what's the difference? Well, in the equation, I have +3, but on the x-intercept, it's -3. And then in my equation, I have x minus 4, I have -4, but my x-intercept's +4. So my x-intercepts are opposite signs. So my x-intercepts are going to be known by the letters P and Q. So if I wanted to know what the intercepts here were, right, it would be P, comma, well, let's go over what an x-intercept looks like. An x-intercept, remember, looks like number, comma, 0, right? So it's always going to be 0 for the y value. So in this case, I don't know what P is, but I know it's going to be the first thing. It's going to be P, comma, 0, and then Q, comma, 0. So I'm going to have 2 x-intercepts there. Now, you can only really write intercept form if you have 2 x-intercepts. Okay, now I do want you to notice, well, let's go ahead and make a note to ourselves that P and Q are x-intercepts. Okay, so P and Q are the x-intercepts. But remember, noticing what we saw on Desmos, right? They're opposite signs in the parentheses. The minus sign in the formula makes them opposite. So you want to remind yourself opposite signs. Okay, and also I forgot to mention these notes are going to be two different sections. The first section we do intercept form, and then the second section we're actually using our calculator to help us solve some area of a rectangle problem. So the second part of the notes doesn't really have anything to do with the first, but I just wanted to put them all in one day just so that we could tackle it all at once. Okay, so just remember that x-intercepts have opposite signs when we're using intercept form. Notice how there's also an A here. A is going to be the same in all three forms, in standard form, in vertex form, and in intercept form. Okay, so examples here. What is my A value here? Now remember, intercept form is y equals A, parentheses x minus p, and x minus q. That's my intercept form. Well, what's my A value here? It is positive 2. So does my parabola open up or open down? This is going to open up because A is positive, okay? A is positive, so it's going to open up. Now, what are my x-intercepts? Well, my x-intercepts here, okay? Now, remember, they're points, right? So you want to write it as number, comma, 0. But you also have to remember they're opposite signs. So my x-intercepts here are going to be next to the x's. My first one would be 3, comma, 0, positive 3. And my second x-intercept would be negative 4, comma, 0. So they're opposite signs, okay? So you want to make sure that you're super careful about the opposite signs there. Okay. Number 2, does this parabola open up or open down? Well, our A value here is negative 3, so it's going to open down because A is negative. Now our x-intercepts here, okay, well, one of our x-intercepts is going to be negative 2, comma, 0, and the other one is going to be, and the other one's going to be positive 5, comma, 0. Remember, it's opposite sides in the parentheses. So you want to be very careful about when you put them in the parentheses, you put opposite signs, and then when you take them out, they're opposite signs. All right, so now we're going to practice using factored form and actually writing an equation. Okay, so write the factored form of the parabola below. Remember, intercept form is also known as factored form. Okay, so the first thing I'm going to do is, if I know I have to write it in intercept form, let's go ahead and identify our x-intercepts, right? So how many times does this graph cross your x-axis? It crosses at 2 points. It crosses here, and it crosses here on the x-axis. Well, one of my x-intercepts, go ahead and write that. My x-intercepts is negative 3, comma, positive, 0, not positive 0. 0 doesn't have positive or negative. Okay, so negative 3, 0. And the other x-intercept is positive 1, 0. Okay, so let's go ahead and plug it into intercept form. So remember, that's y equals A, parentheses, x minus p, parentheses, x minus q, parentheses. Okay, so intercept form. Well, let's plug in what I know. Well, I have y equals A, parentheses, x. Well, what's one of my p? Well, is it 1 or is it 3? It doesn't really matter the order. I'm just going to go ahead and do the 3 first. If you want to write the 1 first, you can. Okay. So one of my x-intercepts is positive 3 here because I'm doing opposite signs, okay? I'm plugging it in for p. Now, could I have plugged it in for q? Sure, but I decided to do the negative 3 first. And then I have x minus q. Well, my other x-intercept is 1, but when I plug it in, it's going to be negative 1. Okay, so far this is what I have. Is this my answer? No, because just like in that first problem, I'm missing my A value, right? So how do I figure out what my A value is? Well, it's going to be very similar, except they didn't give you a point and you have to go find a point. Okay, so let's go find a clean point on this graph. And what I mean by clean point is I don't want to pick this point because I don't know what the coordinates are for that point, right? I want to pick something that's nice. And typically, the nice points are either going to be your y-intercept or your vertex. When you pick the point, again, you want to pick a clean point. A y-intercept or a vertex is your best bet. And if you can't pick either of those, then you can always pick a different point. And I'll show you what I mean by in the second problem. So here, the y-intercept is not a good choice because it doesn't go through tick marks very evenly. But the vertex here goes through 2 even tick marks. So what is my vertex? Well, my vertex is -1, -4. That's a clean point for me to pick. Okay, and using that point, I'm going to use it to help solve for my a value. So remember, a point is listed as x, comma, y. And now I'm going to plug it into intercept form to solve for a. Well, to plug in for my y value, I would plug in -4 equals a. Now, why don't I plug in anything for a? Because I don't know a. Parentheses x. Well, what's my x value that I'm using? -1. And then I have +3. Parentheses, and then I see another x. Well, remember, anywhere you see an x, you're going to plug in whatever that x number is. So you're going to plug in -1 again. And then we have -1. Close parentheses. I'm going to fix this negative sign because it looks funny to me. Okay, now at this step, you want to simplify if you can. So you don't want to double distribute. Like, can you type this in a calculator? Yeah, so you should not double distribute because it would make your life really, really hard. So we have -4 equals a, parentheses, what's -1 plus 3? Well, -1 plus 3 is +2. And then parentheses, what's -1 minus 1? That's going to be -2. Okay? Oh, whoops, that should not be green, that should be blue. Okay, so I'm simplifying things before I do anything. Now here I can still simplify. What operation is in between these two parentheses? Multiplication. So what's 2 times -2? Well, that would be -4. But I don't want to write -4 like this because then it looks like a minus 4. So what's another way I can write -4 times a? Well, I can put -4 in the front. Okay, so 2 times -2 is -4. And then how do I get a by itself? I'm going to divide both sides by -4. And I get a equals 1. Now again, this is not my answer. Just like in the first problem, I want to use it to help me get my intercept form. And every equation in the end should always have a y and an x left over. Okay, so we're going to start. I'm going to write down intercept form again. Y equals a, parentheses, x minus p, x minus q. Okay, and I'm plugging what I know, right? I don't want to plug in anything for x and y. So I have y equals, well, what's my a value? Well, in this case, it's +1. And it makes sense that it's positive because my quadratic opens up. Parentheses x, and then what's one of my x-intercepts? Because that's what p and q are. They're x-intercepts. Well, one of my x-intercepts was -3, so I would have +3. Parentheses, and then I would have x, because I don't want to put in anything for x, and then -1. Is my intercept form complete now? Yes. So this is my final equation. That's my final answer that I want here. So what did we do? So let's go through everything we did. The first thing we did was we ran through the x-intercepts, right? And then we plugged that into intercept form and realized I don't even have an a. So we had to solve for the a. Well, how did we do that? We had to pick a point on our parabola. Any point as long as it's a clean point. We don't want to pick a random point elsewhere. Okay? So now we're going to write down the steps so that we know what to do next time. The first step we did is we want to identify the x-intercepts and one, clean point. Okay, we want to do that. That's the first thing we want to do. We want to make sure that we identify the x-intercepts and identify one clean point, right? So in this case, x-intercepts were in red and our clean point was in purple. The second step after I did all of that, okay, well, after I identified my x-intercepts, you want to write down intercept form, or known as factored form as well, which is, y equals a, parentheses, x minus p, parentheses, x minus q. Okay? After you do that, once we write down that form, then what did we plug in? Well, we plugged in our x-intercepts and we plugged in our point. So you want to fill in the x-intercepts and the clean point, or this chosen point. Okay, now when you're plugging in that x-intercept, you just want the x value. So the zeros here in the x-intercepts don't really matter, okay? So you don't want to plug those in by accident. You just care about what the actual number itself is. Okay, once you fill in the x-intercepts and the point, what did we start doing? Well, we started solving for a. So simplify and solve for a. Once we solved for a, what did we do? Well, then we plugged in our a, our p, and our q. Okay, so that's what we did. We solved for a. That's the whole purpose of what we did. And then we just plugged it into the form and plugged in our x-intercepts also. So phi would be plug in a, p, and q into intercept. Whoops, my handwriting's getting a little sloppy. Into intercept form. All right. Now moving on, we're going to practice again with another problem. Now this parabola opens down, so when I solve for a, my a is probably going to be negative because it opens down. Okay, first step, identify the x-intercept. So notice this is where 0, 0 is, so that means that this is my x-axis. Well, one of my x-intercepts is at negative 2, 0, and the other x-intercept is at positive 3, 0. Okay, so I identified my x-intercepts. And then I also want to identify a clean point. Now, I don't want to pick this point. That would be a bad point to pick. Is the vertex a clean point for me to pick here? No, because it doesn't cross at 2 tick marks nicely. Is this a clean point? Yeah, so if you wanted to, you could pick that point. You could also pick this point over here. But could I also pick this top point, the y-intercept? Yeah. So all 3 of those points are all able to be chosen, and you'll get the same answer regardless. But choosing the y-intercept is going to be the best option because it's always going to be easier for us. Now remember, a y-intercept is 0, number, so this is 0, 3. Okay, so I've identified my 2 x-intercepts and a random point. So now I'm going to fill it into intercept form. So y equals a, parentheses x minus p, x minus q. Okay, and I'm going to plug in all of the information that I know. I'm just going to plug in my x-intercepts first, though, so that I don't do too much at one time. So y equals a, parentheses x. Well, what's one of my x-intercepts? You can pick negative 2 or 3. It doesn't matter. So I'm going to pick negative 2. Well, if I plug in negative 2, it's going to be an opposite sign. So it's going to be positive 2. Negative 2 here, but positive 2 here. You don't change the sign until you plug it in. So this is going to be normal. It's going to be your normal x-intercept, but once I plug it in, then it goes opposite. Parentheses x, and then the other x-intercept is positive 3, but when I plug it in, it's going to be negative 3. Now again, this isn't my final form, right, because I don't know what a is. In order to solve for a, I have to put a point in. Well, I chose to pick the point 0, 3, x, y. So I'm going to plug in 3 for my y equals a, parentheses, x. Well, what's my x here? My x here is 0. And then I have, plus 2, parentheses, open parentheses, another x, but my x is still going to be 0, minus 3, and then close parentheses. So now I'm going to start simplifying. What did I simplify in? What color up there? Oh, I started simplifying in blue, so let me do that. Okay, so let's start to simplify. 3 equals, so next step is to solve for a. A, well, what's 0 plus 2? Well, that's going to be 2, right? Whoops, where did we go? Where did we go? There it is. 2, close parentheses, and open my parentheses again, because 0 minus 3 is negative 3. Okay? So we have 3 equals a. Well, what's 2 times negative 3? That's going to be negative 6. Now, I can write the negative 6 in parentheses if you want, but then it looks kind of funny. So I'm going to rewrite it and write negative 6a. Well, how do I get a by itself? I'm going to divide both sides by negative 6. And I get a equals negative 1 over 2. 3 divided by negative 6 is negative 1 divided by 2. This is my a value, but again, it's not my final answer, right? So we're going to plug it into intercept form, right? So I don't want to plug in anything for x and y. Then I would have y equals my a value, which in this case was negative 1/2, parentheses, x, because I don't want to plug anything in there. One of my x-intercepts, I have negative 2, so it's positive 2 inside. And then I have x, and then, oops, x shouldn't be red. Whoops. X, and then my other x-intercept was positive 3, but when I plug it in, it's negative 3. So that is my final equation in intercept form. Now you're like, well, what if my 3 and my 2 are backwards? This is also an equivalent form. So you have negative 1/2, and then x minus 3 and x plus 2. Remember, when we factored, I didn't care which the order of the parentheses were in. So that's also another correct answer. And for above, in this problem, another correct answer could also be x minus 1 and then x plus 3. Okay, so they're both correct. So I'll go ahead and write both of those just so that you know, hey, they're both correct. All right, so that ends our first part of the video, which is going over intercept form / factored form. So again, to write intercept form, it is called intercept form because it has x-intercepts. And our a value is still our a value. It tells us whether it's positive or negative, opens up or down, and we have to solve for it if they don't give it to us. So now I'm going to start the second section of the video, which is 2 parts. You will need a calculator to do these problems, and so if you don't have one, just make sure you're following along with what I am doing on my calculator. Okay, so number 1, the length of a rectangle is 5 less than twice the width. The area is 322 square feet. Find the dimensions. So the end goal here is to find the dimensions of the rectangle. Well, dimensions are like the measurements of the length and the width. So here we have a rectangle, and I know the area. Well, let's talk about what the formula for area of a rectangle is, right? Area of rectangle. Well, the area of a rectangle is A equals length times width, right? Length times width tells me the area of a rectangle. So I know I'm going to have to use that formula, I just don't know how yet. So let's read our first sentence. The length of a rectangle is 5 less than twice the width. And you're like, whoa, I don't even know where to begin. So the setting up of this problem is probably the hardest part, and then once you have it, then everything else is kind of similar to when we learn systems with substitution. So I'm going to teach you a trick. When you're given a sentence where you're comparing something, right? Because we're comparing the length and the width with each other. When you're given a sentence like that, it's always best to start at the back of the sentence. And this is what I mean. The first thing, if I start at the back of this first sentence, right? If I start at the back, the first thing I see is the width. Well, the width is going to be W, okay? But then it says twice the width. So again, you're reading backwards. So instead of starting at the front of your sentence, we're starting from the back. So it says the width. And then it says twice the width. Well, if I say I have twice as many shoes than you, I have 2 times as many. So I'm going to do 2 times W for twice the width. And then I keep going backwards, and I see less than. Well, less than is what operation? Subtraction. So minus. And then I see the number 5, which means I'm going to write 5 again. So we're reading it backwards, but we're getting our equation from this, okay? And then I have the word is after I have the number 5. Well, is means equals in math, okay? And then it says is, and then length of a rectangle. Well, length is the next thing I see, which is L. So now I have one of the equations, okay? I didn't have to think too hard because I read it backwards. So the first thing I see is width, and then twice the width, so 2W. Then I see less than, which tells me minus 5. Is means equals, and then I have the length. Okay, so that is my equation so far. Now I also know what? I also know that the area is 322 square feet. So using all of this information, I'm going to plug it into this formula for area of a rectangle. Okay, so do I know the area? I do, right? The area is 322. So let's plug that in. So we have 322 equals length times width. Okay, so right now I don't really have much information. I just know 322 equals length times width. But I want to solve this. So just like solving in substitution, I'm going to have to plug something in. Well, L equals 2W minus 5. The length equals 2W minus 5. So L is by itself. L equals. So if L equals, where can I plug this in? I can plug this in for the L because L equals. Now when you plug stuff in, remember you always use parentheses. So equals parentheses 2W minus 5 parentheses, and then I have a W. Okay? Now, we're almost there to where we can actually use a calculator. However, we are not there yet. When you type stuff into y equals, right? So in your y equals screen, you have a bunch of y's that go like this. And normally we type in just the first one, right? When you type in the calculator, are you able to type in on both sides or just on one, right? So what I mean by this is, I'll go to my camera. When you type in your y equals screen in here, are you able to type on this side of the y equals? No, right? So I got to get everything to this side of my equation. So if I need to get one side empty, I'm going to subtract by 322 on both sides. Okay? So let me go ahead and erase all of this over here. All right, so 322 minus 322 ends up being 0, right? Because that goes away. Equals 2W minus 5, parentheses W, minus 322. Now I can type this in my calculator because I don't have anything on the other side over here, right? Now, can I type in W's in my y equals screen? No, right? I can only type in X's. So I'm going to go ahead and translate this into a version where I can type it into my calculator, which is 2x minus 5, parentheses x, minus 322. So now I can type that in. Okay, so let me go ahead and go to my y equals. So I'm going to type in parentheses 2x minus 5, parentheses x, minus 322. Now I use both minus signs here. And then I want to go to my table to help me figure this out. So I'm going to do second, and I'm going to hit the graph button to get to the table up there. Okay, so now I have a bunch of random numbers, right? And you're like, well, I don't even know what I'm looking for. Like, what am I supposed to look for here? So I'm going to show you. Okay, now I want you to look at this equation. Normally on this side of the equal sign, when I type an equation into my calculator, what variable is usually over there? It's usually like y equals, and then I type in stuff, right? So instead of y, what's there in its place? The 0. So what am I looking for? Well, I need to go to my table, and I'm looking for 0 in the y column. Now, why am I looking for 0 in the y column? Because there's a 0 in for y right now. Okay, I'm looking for 0 in the y column. So let me go ahead and go do that. Now, I don't want to go to negative x. And the reason why I don't want to go to negatives is because, well, can length and width be negative? No, right? It doesn't make sense. So I'm looking for 0 in the y column so I can figure out what x is equal to. So I'm going to keep going, and then I notice, hey, I finally see 0 in the y column. Now, why am I searching for it in the y column? Because instead of y, we have a 0 for y. So that's why I'm looking for 0 in the y column. What's next to 0? 14. That means x is equal to 14. Okay, so that means x is equal to 14. But what is x in this problem? Was it y or was it w? Well, remember, when we were writing our equations, what did I have to replace with the x's? Or what did I have to replace the w's with? I had to replace it with x's so that I could type it in my calculator. So x is equal to w in this problem, which means w equals 14, which means the width of this rectangle is 14 feet, okay? Now, is that where I want to stop? No, because it's asking me to find the dimensions, which means I have to find both the length and the width. I want to find both, okay? Now, if I'm asked to find both, well, how am I supposed to find out what the length is? Well, since I know the width is 14, okay, I can plug that in somewhere. Well, I'm going to use the equation that I created at the very beginning. 2w minus 5 equals L. Well, what do I know about w? Well, w equals 14. So I'm going to plug in 14 for w. So I have 2 parentheses 14 minus 5 equals L. So it's very similar to substitution when we learned it. Well, 2 times 14 is 28, and 28 minus 5 is 23. So what does that mean? Well, that means that my width was 14 feet and my length is 23 feet. Now, how can I check to see if this is correct? Well, remember, length times width equals area. Well, if my width is 14 and my length is 23 and I multiply length times width, I get 322, which is what the area equals. So I did this correctly. So the dimensions of this rectangle is that the width is 14 feet and the length is 23 feet. Okay, so those are my dimensions of this rectangle. I didn't have to do a ton of math, but I did need to know what to do with my resources. So now I'm going to begin the very last problem in our notes. The width of a rectangle is 1 less than twice the width. Oh, twice the length, I'm sorry. The area is 45 square centimeters. Find the width. Okay, now in this problem, I don't have feet anymore, I have centimeters. So my width and length aren't going to be in feet. Okay, now again, the hardest part about this is setting it up. Okay, so let's go ahead and translate the first sentence. The width of a rectangle is 1 less than twice the length. Whoa, I'm so sorry. So you want to start at the back of your sentence. Okay, you always want to start at the end. So what's the last thing in our sentence? Length. Remember, length is the letter L. Okay, that's the variable L. And then I see twice the length, which means 2 times L. Now, you're not always going to have a number attached to your variables, right? Like, it's very possible that you just have something like this. Okay, you don't even have a number attached over to L. But in both of these problems, we have. So I'm just warning you that you're not always going to have that. Okay, so we have twice the length. And the next words I see is less than. Well, less than is a subtraction. So that's going to be minus. And then the next thing I see is the number 1, which I'm going to write 1. So again, I'm starting in the back, right? I started with the length, which is L, and then twice the length, which is 2L, less than is minus, and then I have 1. Is means equals the width, which is W. So in the last problem, I had L by itself. Well, what's by itself in this one? W. So you don't want to confuse those, okay? Now, I also know that the area is 45 square centimeters. Okay, well that means I'm going to probably have to use my area formula, right? So area equals length times width. Let's plug in the information that I know. Well, I know area is 45. And remember, area is the letter A. So 45 equals length times width. Well, now I don't have much because I got to solve this, right? Well, W equals 2L minus 1. W equals that. So I can plug that in for the W. You don't want to plug it in for L because it says W equals. And remember, when you plug in, you always use parentheses. Equals L, parentheses, 2L minus a positive 1. Okay? Now, I'm almost to the step where I can calculate something. But in order to put something in the calculator, I got to have everything on the one side of the equation. I can't have something on both sides because I can't type in both sides. So the next thing I would do is I want to get one side equal to 0. So I'm going to subtract 45 on both sides, just like we did with the last problem. We got rid of that number. Well, 45 minus 45 is 0, equals L, parentheses 2L minus 1 minus 45. Now I can type this in, but, sorry, I have to sneeze, so I'm trying to, okay, I went away. So I want to type this in the calculator, but I can't type in L's. I can only type in X's. So I'm going to put it in a way that I can type it in my calculator. X, parentheses, 2X minus 1, minus 45. Now I can type this in my calculator. Okay, so we're going to go to our Y equals and clear out what we have. Whoops. Okay, there we go. So we have X, parentheses, 2X minus 1. So we replace all the L's with the X's, and then I had minus 45. And then I'm going to hit second graph. Well, again, what am I looking for? Well, I'm looking for when Y is equal to 0. And why am I doing that? Because normally on this side of the equation, we have like a Y. But we don't this time, just because of the problem that we have. So we're looking for Y equal to 0. So in my calculator, I'm looking for 0 over here in the Y column. So I'm going to look for it, and these numbers are way too big, so it's probably not over there. Oh, and then it's right here. 0 is in the Y column, and my X value is positive 5. So what I was looking for was positive 5 in the y column over there. Let's go ahead and use the same. So that means x is equal to 5. But what was x in this problem? Was it length or was it width? Well, then you go back to see, well, when did I change it? So here I changed all of my variables to x's. But what did I change it from? Well, originally it was an L. So that means in this problem, my length is x, right? Because I replaced it, right, with an x. It was L and I replaced it. In the last problem, I had W and I replaced that with X. So that means when I found X, it was W. So again, it's not always going to be the same in every problem, right? In this problem, X was W. But in the second problem, X is L. Again, it depends. So that means X is equal to 5, which means length is equal to 5, which means my length is 5 centimeters. Okay? If the length is 5 centimeters, well, what did they ask me to find? Well, they asked me to find the width, so I haven't even found what they wanted me to find. Well, since I know the length is 5 centimeters, how can I find the width? Well, I can use that original equation I had, 2L minus 1 equals W. Okay? Now, I know that length equals 5. L equals 5. Well, where can I plug in the 5? I can plug it in for the letter L, because L equals 5. So then I have 2 parentheses 5 minus 1 equals W. So then I have 10, because 2 times 5 is 10, minus 1 equals W, and so I have 9 equals W. Well, what does that mean? That means my width is 9 centimeters, and I found what they asked me to find. How could I check to see if I did this right? Well, remember, length times width should give me the area. Well, the area here is 45, and if I do 9 times 5, which is the length, I get 45. So I found what I needed. All right, so that is the second half. It had really nothing to do with the first half, but I did want to put in some extra application problems to solve for the area of a rectangle. If you have any questions, please feel free to come in for tutoring.